Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this video, we're going to take a very important step in optimizing our code for the least amount of computation when we go about data preprocessing. In this video, we're going to see the comparison and contrast between looping, applying a function to your data frame, and vectorization and broadcasting, and see their differences and their advantages and disadvantages. And it's going to give you a very good understanding and a set of skill set that will set you apart as far as being able to write a code that is going to run much faster significantly than the codes perhaps you've been writing. All right, let's get started. Okay, so let's go ahead and get started with first importing our modules. First of all, we're going to create a dummy data here to be able to see the differences that we are going to see between looping, applying, and vectorization and broadcasting. As we get through these, I'm going to also provide a very quick introduction to each of these, right? So I'm using NumPy to, random NumPy normal distribution to create a data set of 30,000 people with their height and weight, right? This is just a random node data that I'm creating, just something to start working with. So you can see we've got 30,000 rows and 2 columns of height and weight in centimeter and kilogram. All right, so this is just a data set to start seeing some examples, right? So for this data set, we want to calculate the BMI. BMI is an index that is used by the health professionals to indicate how healthy of a weight to height ratio you have, right? So BMI is basically your weight divided by your height in kilogram powered to 2, right? So this is the formula for BMI. We're going to basically use a few different approaches to go about calculating BMI and seeing the differences that they're going to have. So if you don't have much programming experience with data, you might do something that might sound intuitive to you to calculate the BMI for each of these individuals by looping through this data frame, looping through all of the rows, and grabbing these values and calculating the BMI and inputting it as the third column, as BMI, right? So this is the first approach, right? This is a traditional loop that if you don't have a lot of programming experience, you might go for, right? So in this approach, first thing you would do, you would create a column as a placeholder, and then you would create a loop, right? You would go over all of the rows once in this iteration and calculate the BMI, right, by getting the weight and the height and applying the appropriate formula, right? So this is that line of code that would loop through every row to calculate this. You can see I've also added this piece of code here. This piece of code is specific to Jupyter Notebook, and what it's going to do for us, it's going to time how much time this is going to take for it to run, right? So let's run and see how. All right, so only for 30,000 rows, right, it took 40 seconds for this calculation to happen. 30,000 rows in this day and age is not a huge data set, right? We are talking about millions, hundreds of millions, and billions of records sometimes when it comes to data analytics and data preprocessing, right? So right off the bat, we can see using this type of processing, it may not be the best way to go about this, right? So we try to improve this by saying, okay, I know that pandas, the module we are using, has its own iteration and looping. Let me see if that's going to help anything, right? So instead of using the typical Python loop, we use the pandas, its own loop, like iter rows, to create iterations over the rows, and we are going to have access to the index and the row and calculate the BMI in this way, right? So let's see how much this is going to last. Okay, we do see a slight improvement from 40 seconds to 32 seconds, but still this is significantly large number for only 32,000 data, right? So this is still, there's some improvement that we can make by changing approach, right? So one of the ways you could not only make your code faster but also make your code more readable is to start using the pandas apply function. Basically, you create a function that you mean to apply it to each row, and that function would have a return, and then you apply that function to all of your rows and you would get the results, right? So for instance here, if we were to use the apply an explicit function approach, which is the third approach we're talking, we would create a function, right, like any other function, would say the input of this function is a row and the output is a calculation that we would do for the BMI, right? So we call it a calculate BMI. Once we define this function, then we can use the pandas apply function, the data frame apply function, to apply this function to every row. Pay attention, this is specifying we want to apply this function to every row, right? So let's go ahead and run this and see how much this is going to take. Alright, so we managed to make this much faster, right? It used to be 40 seconds, now it's 1 second, right? So we can see starting to use capabilities of pandas is going to start like paying off as far as computation. I've seen times and again in many resources that basically using apply function is the same as looping. We can see that's not the case. When you use apply function, what happens is you give more of your control as far as what's going to happen behind the scene to pandas, versus when you use a loop, you literally say, I want to be in charge of everything. I want to actually be looking at, I want to take every iteration and do the calculation myself, which might be the appropriate thing to do based on the analytics you need to do. I mean, there are a lot of times people say you never want to have a loop in your code. I don't go as far as saying that. Most of the time, 99% of the time, you can get by and have a better code without a loop. But at the same time, we can see, using apply function is not equal to loop. There is much significant improvement if you were to use apply function instead of looping, right? So we were able to, improve this 40 times, like 40 seconds to 1 second, right? So this is a significant improvement. And if your analytics allows you to use, to apply a function instead of using a loop, you should go for this. I mean, not only is it going to create your code faster, but also it's going to create your code more readable, right? Once you start, feeling more comfortable, you see the function and you just apply it, right? So this is a way cleaner code also. Not only it's faster. Another approach which is very similar to the third approach is like changing that function, the explicit function, to a lambda function. I mean, lambda function is a function you basically write on the fly. I mean, you just write the function on the fly. This is a whole representation of the function, right? So here, your code becomes even more condensed and also faster. You can see it takes as much as the other code, like around 1 second, right? So apply function, whether we use explicit function or lambda function, is better than looping, not only as far as computation, which was way fast, but also as far as code's readability. The fourth approach that we're going to start talking about is vectorization and broadcasting. Basically, when you use vectorization and broadcasting, you give all of the calculation, push them all the way to the CPU level. Instead of bringing them into an iteration, all of the data is in the CPU, and that in the CPU, when you have two vectors, two list of numbers, you say, I want to add these two. So it happens right there, and it's just much faster. Or with broadcasting, if you have one value and you have a collection of items, this will be broadcasted to each of these values, right? So with broadcasting and vectorization, you start taking advantage of CPU level calculations, and that is a huge significant difference that we can see this is going to make, right? So instead of sort of like taking the things into our own account, having a function or like having a loop, we basically say I have a list of weights and I have a list of heights, right? I divide all of them by 100, so this is broadcasting. You've got a list and one number. You want to divide all of these by 100, and then you want to multiply that by you want to make that power to 2, right? And then this is another broadcasting. So you have the same number of lists here, like the same number of numbers on the height. Now the same number of numbers on the weight. Now you use vectorization to make this calculation, right? So let's go ahead and see how long this takes. 2.9 milliseconds. You can see this is way faster than applying, and way faster than using a loop, right? So using an apply function is still better than using a loop to do your calculations, but at the same time, using vectorization and broadcasting, if you can manage it and if it's possible, it's always better as far as your computation. So let's make it a little bit more complex, right? So it's never, using vectorization and broadcasting is never as straightforward as this. Just, actually someone might come out and say this is even more intuitive than what we were doing before. It's not always this very simple for you to use vectorization. You have to be able to manage some challenges along the way. So let's create a situation that for us to use vectorization, we have to learn a little bit more, right? So I expand my data frame into including also a gender category, a gender attribute, right? So now I'm using a binomial normal distribution and add this gender to my data, right? So now I want to use gender and BMI to figure out who is a healthy individual, right? Who are the healthy individuals? So men whose BMI is smaller than 20, these are underweight. BMI between 20 and 25, these are healthy. BMI larger than 25, these are overweight. For women, it's a little bit different. BMI smaller than 19 is underweight. BMI between 19 and 24 is healthy, and BMI larger than 24 is overweight, right? So now we want to see the differences between how we can use what we should be using to do this most effectively and fastest, right? So again, the first approach is to take everything into our own hand and create a loop and have some conditionals to go over this. So just for the sake of seeing how it would look like, let's go ahead and run this. All right, so we can see it took around a minute to run, right? So now we create a function so we could apply it to our data, right? So instead of doing a loop, we create this function, and now if we do this is going to be much faster, around 2 seconds, right? So we can see that we're still getting a lot of improvement if we were to use the apply function. But if we were going to use vectorization, because this if conditionals are going to be a little bit more involved for us to be able to actually do this in a manner of a line of code, which is not possible here really. We have to use other tools. Here we have to use NumPy where function, which basically allows you to have a condition and a response, right? So you can see I have used the np where function in a nested way to be able to manage to calculate the status based on gender and BMI, right? This is not as readable as doing apply function in this situation, but it is way faster, right? Again, 6 milliseconds, thousands of times faster than by using apply function. So the efforts you would take to make sure that you're taking advantage of the vectorization and broadcasting is always worth it. If there is a way you can do it using vectorization and broadcasting, you should try to find it and go for it. Based on different situation, this might become more challenging and more difficult. You have to use different tools and functionalities to be able to do it. But again, that's something you want to do. And I will start and I will continue introducing you to the ways that you could go about this, and also bringing up challenges that this will allow you for you to learn those different functions. So you might want to stick around and watch more of my future videos. So the last thing I want to say is that these operations that most of them are very familiar to you, like addition, subtraction, division, so on and so forth, are available for vectorization and broadcasting operations. So if the analysis you're doing only involves one of these or combination of these, you don't want to use any other methods. You want to use broadcasting and vectorization. Try to figure it out for your code to be optimized. If this goes beyond these operations, that might be the time for you to start thinking about applying a function to your data frame. All right.